Okay, at this time we're going to go ahead and do our gas heating diagnostic modules number 3 and 4. And as a quick reminder, if you are participating in this meeting, you would be recorded, so we will be recording this session today. So welcome to the program. Today we're going to be talking about the Johnson Controls single-stage and two-stage gas furnaces. Specifically, some features we're going to be talking about today are going to be sequence of operation for single and two-stage furnaces. We're going to discuss safeties and their proper position for normal operation. We're going to discuss flame proving and the importance of flame proving, and then normal operation and indoor blower on delay timings. So in this portion of the program, we're going to learn about the sequence of operation. Now, this is very, very important. If a technician can fully understand what's supposed to happen in sequence, I believe it makes him a better troubleshooter. So referring to your workbook or your handout pages 6 through 13, you can kind of follow along. Now, it should be noted, team, I will not be reading the text to you, but we will be talking about normal sequence of operation. So if you'll listen to the recording as well as kind of follow along, as we're going to be skipping around some between pages 6 through 13. But as you listen to the recording, you'll be able to kind of follow along as we talk about how it works. Again, I'm not going to be reading it to you. So by all means, use your text in your materials, but understand that it's going to be sequence of operation and how it works. So we're going to talk about proper switch position for a heating call. High temperature safety circuits. We'll be touching on igniter warm-up sequence and how long the igniter warms up. We're going to be talking about indoor blower on delay timing. And then finally, flame proving and the importance of flame proving. Now, we learned in our previous modules, number 1 and 2, that grounding is extremely important for flame current sensing. Well, part of that flame current sensing circuitry is the flame proving, or the FP circuit. And so it's important that we have to have good, solid grounding. I can't stress that enough. And as we talk about our flame proving and the importance of it, we have to keep in mind that we're going to be measuring that flame current in microamp DC as we discussed in our previous modules. So single stage sequence of operation. Again, team, I'm not going to read it to you, but I am going to talk about how it works. So we can see on page number 6, we have a little schematic down below, a little wiring diagram. So what happens electrically at the thermostat when it calls for heat? So what's going to happen electrically, the thermostat is going to connect 24 volts between R and W. Once the furnace sees a W call or a W signal, 24 volt signal on the W terminal from the thermostat, what it does is it goes out and it checks all the safeties. Make sure all the safeties are closed. In addition, it makes sure that the pressure switches are open electrically. Now, this is an important concept. All the safeties have to be closed, but the pressure switches have to be open electrically. Then what happens in our next sequence of operation is the induced draft blower starts. Once the induced draft blower starts, it's going to generate a negative pressure. That negative pressure, or that vacuum, is going to suck those pressure switches closed electrically because they're open, they're normally open, they're a negative pressure switch, and when the induced draft blower energizes, it's going to suck those pressure switches closed electrically. Once those pressure switches are closed electrically, in other words, once we've proven our vent pressure, because the induced draft blower is going to be sucking, through the vestibule assembly and then blowing out the vent pipe to go outside. And so it has to verify proper vent operation, and it does that with the pressure switch. So again, those are negative pressure switches that are normally open on a call for heat. And so once the thermostat calls for heat, the furnace goes out and it looks at all the safeties to make sure they're closed electrically. And then it starts the induced draft blower and it sucks the pressure switches closed. Now, we'll talk about how to check that pressure switch closing a little bit later on, and we're going to talk about testing vent pressure a little bit later on. But for right now, we just need to remember that the induced draft blower sucks those pressure switches closed. Once those pressure switches are closed and it's confirmed that they're closed electrically by the control board, and again, we'll talk about testing them later on with a magnehelic gauge and how we'd hook up our voltmeter and all that kind of stuff. But electrically, when that switch closes, it reports to the board that the switch is closed and that we have a clear vent. Once we have the pressure switch closed and we're satisfied that the venting is clear and we don't have any obstructions in it. The next thing that happens in the sequence of operation is the igniter warm-up sequence. So in other words, we put power to the hot surface igniter, and it's going to warm up for 17 seconds. After the igniter warms up for 17 seconds and it's just glowing white hot, it's a 17-second warm-up, we then open the gas valve. Once we open the gas valve, the hot surface igniter is going to ignite the gas. We're going to establish a flame. Once we establish that flame, we're going to sense the flame. Excuse me. We're going to sense the flame on the flame sensor. Once we sense the flame, a couple things happen. Number one, the hot surface igniter shuts off, and we start our indoor blower on delay timing of 30 seconds. 30 seconds later, the indoor blower comes on, and we're now distributing heat throughout the conditioned space. That's how a single-stage furnace works. And so again, as a quick summary before we get into two-stage sequence of operation, the thermostat calls for heat. We get a W signal on the 24-volt terminal on the furnace. It then goes out and checks all the safeties and it makes sure that the pressure switch is open. We then start the induced draft blower and we suck the pressure switch closed. We then start our igniter warm-up sequence of 17 seconds. 17 seconds later, the gas valve opens electrically and mechanically, and it allows gas to flow, and we establish flame. Once we establish flame and we sense the flame on the flame sensor, we shut the hot surface igniter off, and we start our indoor blower on delay timing, factory setting of 30 seconds. 30 seconds later, the indoor fan comes on and we distribute heat throughout the conditioned space. That's how it works. Now, two-stage sequence of operation is very, very similar to a single-stage furnace in the fact that the thermostat still is going to send a W signal to the control board. Once that control board sees the W signal, it's going to go out and check all the safeties, make sure all the pressure switches are open electrically. Only this time now, if it's a two-stage product, it's going to start the induced draft blower on second stage. It's going to start the induced draft blower on high, in other words. It'll then close all the pressure switches, because remember, on a two-stage product, you're going to have more than one pressure switch. So the induced draft blower on a two-stage sequence of operation closes both pressure switches. Once both pressure switches are closed electrically, it'll then start our igniter heating, our igniter warm-up sequence of 17 seconds, just like before, and then it'll open the gas valve on high fire position. Once we open that gas valve on high fire position, we'll then establish flame on high fire. And once we prove that the flame is on high fire with our flame sensor, what will happen if we're only calling for a first stage heating, another W1, if we're only calling for first stage heating, during that 30-second time delay before the indoor blower comes on, the gas valve will back off to first stage, and then when the indoor blower timing of 30 seconds is over, it'll bring the blower on first stage heating speed. Now it should be noted that we always fire the furnace on second stage to exercise the gas valve as well as the high and low aspects of the induced draft blower and the high pressure switch. All of those components get exercised each time. So unlike our competitors that do not use that sequence of operation, we want to make sure that everyone understands that on the Champion furnaces, we always fire them on second stage gas heating to exercise the gas valve and to make sure all those components work each and every time. Then, if we're only calling for a first stage heating operation, W1, after we prove flame and during that interim time before the indoor blower comes on, we'll then back off to first stage on the gas valve and back off to first stage on the induced draft blower, and we'll also open the second stage pressure switch, and now we're running on first stage. So if you get a question on your post test that says, how much time delay is there between W1 and W2, first and second stage heating, the proper answer would be none, because if you understand this, we see that we fire the gas valve and we fire the furnace on second stage every time, and then we back off to first stage if we only have a W1 call. Now let's say, for instance, the thermostat, let's say it's cold in the space, or maybe the thermostat is coming out of setback. And the thermostat electrically calls for W1, first stage heat, and W2 second stage heat at the same time. Well, the control board is just going to see a W1 and a W2. It's still going to go through its normal sequence of operation. It'll go out and check all the safeties, just like before. It'll make sure all the pressure switches are open, just like before. It'll go ahead and start the induced draft blower on second stage, just like before. It'll suck both pressure switches closed, and then we'll start our igniter warm-up sequence of 17 seconds. 17 seconds later, the gas valve will open on second stage. We'll fire it on second stage, and once we prove that flame on second stage, and we have flame sensing on our flame sensor on second stage, now during that 30-second interim time before the indoor blower comes on, if the furnace is calling for W1 first stage and W2 second stage, it just stays there. Then 30 seconds later, what will happen is the indoor blower will now come on second stage heating speed, and now we're distributing heat throughout the conditioned space on second stage. So it's very, very important we understand on a two-stage furnace, what we do is we always fire it on high fire, and then we back off to first stage if necessary during that 30-second interim before the indoor blower comes on. And so if you're questioned about this, or if you want to talk more about this, remember we do this for reliability. And this is one of the really nice things about the Champion furnace. We like to make sure the components are working each and every time. And so for reliability, we exercise the gas valve. We exercise the pressure switches. We exercise the induced draft blower on high speed every time we call for heat. And then if we only have a single stage heating call, or the first stage heating call, then what will happen, it'll back off into it as we described. So two-stage sequence of operation, again, is very, very similar to first stage or a single stage furnace, except we always fire it on second stage, and then we back off if necessary. At this time, we would normally have a break, but because this is a recorded session, we're going to just press on through the recorded session for your convenience, and so you don't have to actually wait on the next module. So let's go ahead and look at gas heating module number 4. This will be our final module for gas heating module. And so on gas heating module number 4, welcome to this portion of the program. And some key topics we're going to be talking about is testing vent pressure and the proper use of the tools to check vent pressure. We're going to be talking about testing gas pressure for a single and a two-stage furnace, and measuring flame current and reviewing flame rectification, or the science of flame rectification, also known as flame sensing. So let's talk about testing vent pressure. So measuring vent pressure and finding the cause of low vent pressure is an extremely important skill every technician needs. And so we're going to discuss the following: how to attach the test hoses, calibrating the Magnehelic gauge, measuring vent pressure, and then confirming proper vent size from the table. So in your workbook, and more specifically in your handouts, if you just have handouts or the gas heating workbook, you'll find there are going to be some vent tables in there that you can actually look at to measure and to make sure that the proper size vent pipe is hooked up to the furnaces based on how large the furnace is and how long the vent pipe is. So the first thing we want to do when we check vent pressure is we want to identify the switch that we want to test. Now you're going to notice on our Champion furnaces, the switches are going to have a data plate on them. So find that data plate or that data tag on the switch, and you'll notice that somewhere on that data tag it's going to have a negative number. That negative number is going to be the operating pressure or the operating point of that switch. Now remember, team, this is a negative inches of water column pressure. In our example on the data tag that we see on our PowerPoint, the closing pressure and the operating pressure, also called the closing pressure, on this switch is a negative 0.5 inches of water column. So please write that down and remember it as we continue through our slide presentation. So a 0.5 inches of negative water column is the operating or the closing pressure of this particular switch in our example. So again, we identify the switch that we want to test as we take a look at our furnace pressure switches behind the service panel. We then remove the hose that's going to the switch that we want to test. And then we're going to tee into that hose with another piece of hose that we're going to go over to our test instrument, either a Magnehelic gauge or a digital manometer. So we remove the hose from the switch to be tested, and we're going to tee in another hose to go to our test instrument. In our example, we're going to be using a Magnehelic gauge. However, a digital manometer will work just as well. Just make sure that before you use a Magnehelic gauge or a digital manometer to be sure and calibrate or zero the gauge. We want to make sure that we have a good accurate reading, and the best way to do that is to hook the hoses up, where you've teed into the switch that you're going to test, and then calibrate it to 0. And then again, we're going to hook that hose up to the T on the pressure switch that we're testing. We will then start the furnace and let it establish normal operation in the heating mode of operation. And then we're going to physically read, or we're going to measure the vent pressure on the switch that we're testing. So if we recall, the switch in our example had a 0.5 inches, negative 0.5 inches water column closing pressure. Well, in our first example here, we see we have a negative 0.85 inches of water column that the furnace is actually pulling or producing on that pressure switch. So it's more than enough to close that pressure switch and to maintain normal operation. So we're in good shape on that one. In our second example here, we see that we've got 0.65 inches of water column. Now remember, team, the closing pressure on that switch was 0.5 inches. And so we're well beyond that 0.5 inches of water column. So even though the vent pressure is actually a smaller number than it was before, it's a negative pressure, it's a smaller number than it was before, what happens is the furnace is still able to operate and maintain a good vent pressure for normal operation. Now, it should be noted that if you start having vent pressures that are very close to the switch closing pressure, you need to investigate. In other words, if we had a 0.52, or if we had a 0.55, or we barely had a 0.50, we'd want to investigate, because that's a little bit close. The switch tolerance is a little bit close, and so we want to make sure that we have the proper size venting and so on, and we want to make sure we don't have any water that's stuck in the vent pipe, or we don't have a sag in the vent pipe and that type of thing. Because what can happen if you have low vent pressure, we need to make sure that the vent pipe is clear. That's the main thing that switch is there for. It's a safety switch to prove venting. So in our final example here, we see that, our furnace is actually generating a 3 flash code, which tells us we're not closing that pressure switch like we should. As a matter of fact, when we look at our vent pressure, we find out that we're only generating a 0.30 inches of water column, and it's low. And so again, some of the things that we may want to check, we notice that the LED flash code indicates that we're not closing that switch. And so we're having a problem closing the switch in this final example. And so let's ask ourselves, what are some of the things that we should check? Well, some of the things that we should check to make sure there's no debris in the vent pipe, especially if the furnace has been installed for a couple of years. Maybe some squirrels or critters got in there and deposited some debris in the vent pipe, so we want to make sure the vent pipe is clear. We want to make sure there's no long runs on the vent pipe that have sagged over time and that are holding water and acting like a water trap. So make sure that the vent pipe is installed according to the install guide, and that normally indicates a pitch towards the furnace, so we don't have any sort of trapping or water trapping in that vent pipe. And finally, check those vent tables. If it's a brand new installation especially, make sure that the vent pipe is the proper length and the proper size for the furnace that's been installed. In addition, make sure there's not excessive elbows, because if we have excessive elbows in that vent pipe, what will happen, it can add equivalent length and can cause an issue with our vent pressure. So these are all some good things to check. Look at those vent tables. You'll find that in your handout or your workbook. And more importantly, with every furnace that is shipped from Champion and Johnson Controls, you'll find there will be an install guide, and that install guide will have vent tables in there appropriate for that furnace. The next thing we're going to talk about, team, is measuring gas pressure and making adjustments And this is, again, is a very, very important skill that every technician needs. So please follow along as we discuss the following. We're going to talk about some of the gas valve features that are specific to the product that we use, attaching hoses to the gas valve, single and two-stage gas valve adjustments and where we would find those adjustments, and measuring inlet and outlet gas pressure with a Magnehelic gauge, a digital manometer, or a water manometer is sufficient for gas pressures. So as we take a look at our gas pressure, our gas valve and some of the features of the gas valve, we said that we have inlet gas pressure and outlet gas pressure going through the manifold and coming into the valve. Now remember, team, based on if it's propane or natural gas, those pressures will be different based on the fuel gas that you're using. You'll notice that on the gas valve itself there's normally an arrow that indicates gas flow, and that's stamped right into the valve itself. In addition, on this particular type of gas valve that we use a lot of on our Champion furnaces, you'll notice that the posts on the gas valve body are used for pressure measurements, so you don't have to have a lot of special fittings or hose barbs or anything like that. Now, based on the product you're looking at, you may still have to have some, but this particular type of gas valve, the posts for measuring gas pressure are actually built in on the gas valve body itself. And because there's no longer a need to adapt the inlet and outlet pressure taps with hose fittings, you will have to have a small piece of hose with a hose barb so you can hook up your test instrument. In addition, you're going to have an Allen wrench so that you can open up the little valve test port on the gas valve itself. So we see a picture here. We've got our adapters, our little hoses and our little adapters hooked up for our test instrument. You'll notice that the inlet pressure post is on the front side of the valve. The outlet or the manifold pressure spot is going to be on the back side of the valve on this particular valve arrangement. You'll also note that the tubing slides right over the post. There's no need for an extra fitting with this configuration. So looking at the valve from the top, you're going to notice that on a single stage valve, and you can refer to pages 30 and 31 in your workbook, your handouts for single stage gas pressure settings. What you're going to do, you're going to remove the cap on your adjuster or your adjustment screw. So remove the cap to adjust the pressure. And then on the actual posts themselves where that Allen wrench goes, you're going to loosen that Allen screw about 1 turn on the inlet and on the outlet, and then you're going to slide your hose over so that you can hook it up to your test instrument to check your gas pressure. So take that out about 1 turn. On a two-stage valve, you'll find that the gas pressure settings for a two-stage valve will be found on page number 32 and 33 in your handouts or your workbook. Now, it should be noted on a two-stage valve, you're going to have a high and a low pressure cap to remove. And those brass caps you'll find, again, you'll just remove those with a screwdriver. And underneath those brass caps, you'll be able to find your high and low pressure adjustments for your gas pressure adjustments. Now remember, please note on some valve models, you have to change the spring underneath the high fire adjustment for propane conversion. Some valves don't require that. However, look at your gas valve propane conversion kit, and if there's a spring in there, you automatically know that that goes under the high fire for propane conversion. So on a propane conversion, don't forget to adjust the gas pressure when you've replaced that spring, and you have to make sure that you adjust both the high and the low pressure on a propane conversion. So first thing you do, step number 1 on a propane conversion, after you change the spring, you're going to call for W1 and W2 together on a two-stage furnace. And you're going to adjust the high fire first. You'll then call for W1 or low fire only and adjust your low fire pressure. So this is an important sequence. You change the spring if necessary underneath the high fire. You then put the furnace, you then start the furnace and get it all back together and get it going. And then you adjust your high fire first. So you call for W1 and W2 first and adjust your high fire gas pressure setting for propane. You then call for W1 first stage by itself and then adjust your low fire. So high fire first and then low fire on a 2-stage gas valve propane conversion. So when you're testing gas pressure, again, pages 30 through 33 will give you your gas pressure settings for both a single stage and a 2-stage furnace. And it should be noted that based on if it's propane or natural gas will be the appropriate gas pressures for inlet and outlet. Now, team, what I like to do when I'm actually checking gas pressures on a gas valve, I like to have 2 gauges. I like to have one on the inlet and one on the outlet. So in our example right here, we see that on our inlet pressure, this is natural gas. We have 6.85 on the inlet, and we've got 3.74 on the outlet on this particular gas valve arrangement. And so I like to do that when I make a service call on a furnace, only because I like to see what the gas valve is doing. And so I like to measure both the inlet and the outlet together. At the same time, when I check a gas valve, it gives me a real good idea on how the valve is operating and so on. And so if you can take them individually, but again, a service tip on my part is to take your inlet and your outlet gas pressure together with 2 separate gauges, just to really give you a good view on how the gas valve is operating. And again, pages 30 through 33 in your workbook or your handouts to find the proper gas pressure for propane, single stage and 2-stage, or a natural gas furnace, single stage and 2-stage, on those pages 30 through 33 in your workbook. The next thing we're going to talk about is measuring flame current. Now, I recommend that a technician measures flame current every year when he does his cleaning check. And if there's any difference than the previous year, to please log that in, and to keep in mind that the main reason you would have low flame current is for poor grounding. So if you have poor grounding on the furnace, or if you've got a ground wire that's starting to get corroded and so on, that can affect your flame sensing. So let's talk a little bit about flame current and the science behind flame rectification and how that works, and then actually measuring flame current as we start rounding out the conclusion of Module 4 today. So flame rectification is very, very simple. Basically what it does is we put an AC voltage on the flame sensor anytime the furnace is powered up. So I want to stress this to everybody. There's 115 volt on the flame sensor all the time, but hang on a second, it's an extremely high resistance circuit. So there's no current there to speak of. If you were to touch that flame sensor, it's not going to shock you. If you were to short that flame sensor against the chassis ground or the burner assembly, it's not going to burn anything up. It's an extremely high resistance circuit. However, it is line voltage driven. So on the purple wire going to the flame sensor, anytime there's power on the furnace, there will be line voltage, AC voltage, on the flame sensor. Now it should be noted, if the flame is absent, there will be no current flow to ground or through the grounding system. This is why it's so important you have to have good solid ground, because the other side of that flame sensing circuit is actually the chassis ground. So if no flame is present, nothing happens. It's just an open circuit. However, when we apply a flame to the flame sensor that we see in our next graphic here, what happens is the voltage, the AC voltage on the flame sensor goes through the flame to the burner and then goes along the chassis ground, along the ground plane. Now it should be noted the flame has an interesting characteristic. It actually cuts that voltage in half, or rectifies that AC voltage into a pulsating DC voltage signal. So what happens is the flame actually rectifies or converts that AC signal to DC voltage. And then that current, the DC current that flows through the ground, is actually sensed by the control board, and it allows gas to continue flowing. Now, if the control board does not see pulsating DC along the ground plane and the flame sensing circuitry, it then shuts the gas off, and it'll throw a code, or it'll indicate a code of no flame sensing. So it should be noted, this is why we stress so much that you have to have a good, clean, solid ground on the chassis ground in the furnace in order for the flame to be sensed. Because this flame rectification, the science behind the flame rectification is we put AC voltage on the flame sensor, and then the flame, if it's present, converts that AC voltage into DC, pulsating DC, which is then sensed by the control board and allows the furnace to continue operating. Now remember, as we said before, and I know I'm stressing this many times, a good clean ground is required. In addition, to maintain proper flame sensing, the polarity between neutral and hot, or neutral and line voltage in the incoming power has to be proper polarity. So there has to be, the neutral wire has to be hooked up to the white wire, and the hot or 120 volt AC hot terminal has to be hooked up to the black wire, and then the green wire or chassis ground. They all have to be correct from the power supply in order for it to sense flame properly as well. Now, to measure that flame current, what we're going to do, team, we're going to find our flame current pad on the control board, and we're going to call for heat. Now, if it's a single stage furnace, you just call for W. If it's a two-stage furnace, just call for W1. But either way, we're going to let the furnace establish normal flame. We're then going to set our meter, our voltmeter, to DC volts. And we're going to select a very low scale, because it's not going to be very high of a scale. In other words, a normal flame current will be somewhere between about 3.5 and 4. So set your voltmeters to, say, 10 volt scale, or the lowest scale that'll accommodate 3 to 4 volts DC. And then we're going to measure DC volts on the flame current pad. Now remember, team, 1 volt DC is equal to 1 microamp DC flame current. And as we measure that flame current, remember, it should be above 1.5, because at 1.5 microamp flame current, it'll actually generate an amber flash code if it's below that. So remember, at 1.5 and below, it'll generate an amber flash code. If it's above 1.5 microamp DC, it won't generate a fast amber flash. You'll just have normal operation. So the flame current should be above 1.5, and typical flame current is about 3.5 to 4. Well, team, that concludes our Module 3 and 4 recording for our gas heating Module 3 and 4. Thank you so much for your attendance and your listening to this recording. Please stay tuned with our wind supply coordinator, Jill Pauley, and she will be setting up additional training sessions, live training sessions, and by all means, we ask that you please attend those as well. But again, thank you, and have a great day, and please be safe out there. Thanks.